So one is our vectorized query engine with SIMD, right? So vectorized, for all intents and purposes, right, means that you store the data in columns from that standpoint, right? Why in columns, right? Well, most of the time for an OLAP database, you're actually doing aggregations. So you're talking about summations, or you're talking about some type of, like, the summation would be, give me all the sales for the end of the week, right? Tell me how many employees are in this region, right? Uh, you know, things of that nature, where you're applying an operation to the same set of data, but it's a lot of that data, right? That's one piece, right? The other, and there are other, databases on out there that are vectorized from that standpoint. Which I would say majority of the market right now, probably more than 50%, has moved to vectorized, when in the past this wasn't the case, right? But what is unique is this SIMD. So SIMD stands for single instruction multiple data. So a lot of the databases out in the current market is that for one, say for instance, CPU cycle, you can do one operation, either a read or a write. An SIMD, single instruction, multiple data, it implies that for a single instruction, I will work on multiple pieces of data at the same time, right? Now, think about that. This technology doesn't really work well for OLTP, like MySQL and Postgres, because you're usually only manipulating one row from that standpoint, right? But when you're doing an operation like summation, you're actually applying the same operation across multiple pieces of data, a range of data from that standpoint. And this is where that SIMD was really, really, great for us to go use, right? And although this feature has been in Intel chips for a while from that standpoint, it was only theoretically used written in academic papers about 10 years ago. And the newer generation of OLAP systems, in fact, inside of the OLAP world, I only know of 3 databases that uses SIMD. Obviously, we're one of them from that standpoint. And this is why we dominate, is the performance charts from that standpoint. Also, as a little tip, so what was SIMD really originally built for? It was actually built originally for gaming and for music. So the idea here is that if you had a game with light rays, instead of you doing a for loop and individually moving each particle of light in the game, is that you can apply is an operation to move all that light as an entire series, right? And so you can imagine doing the same thing. Instead of us manipulating every single individual row or column from that standpoint, or every single entry, we apply an operation across everything. And that allows us to be 3 or 5 times faster than other non-SIM databases.